Now we're going to see a method of implementing Gaussian elimination in Octave. Gaussian elimination, as you remember, is a process where we eliminate some of the variables from the equations. So this is an example of a linear system with 4 equations and 4 variables. Now you may be asking, why do we have x1, x2, x3? Well, because eventually we could have equations with several variables, with 10 variables or 20 variables, then I couldn't use x, y, z, w. It would be impossible to list all the variables, to give names to the variables if we have a system with 20 variables. So we simply use x with an index. Okay, so this is the first variable, second variable, third variable, and fourth variable, and so forth. Same thing with the coefficients of those variables, right? So we say a11, that's the coefficient of the first equation and first variable. So we can always write a system of linear equations in this form. Okay, the idea of Gaussian elimination is to eliminate these terms here. So we'll do operations that will eliminate these coefficients. Now what are those operations? The operations that we do with linear equations, right? We can always add 2 equations in the system. We can multiply one equation by a number. We can multiply one equation by a number and add to another equation. So those are called row operations. For those of you who took linear algebra before, you remember that very well. So Gaussian elimination, then we will eliminate these terms. And what is the purpose of that? Well, the purpose is to get a system that is much easier to solve. For example, if these are eliminated, then look at what we have now. It's much easier to solve. So we have this system here. And we can use something called back substitution to solve for the variables. So from this equation here, we go to the last equation and solve for x4 in this case. So this would be b4 over a4, right? Once we get x4, then we can easily get x3 from the other equation right above that equation there. So we have x33, just x3, right? So we're solving for this variable. We move this term here to the other side, so this would be b3 minus a34 x4, and then divide that by a33. Okay. Now then we can find x3, because at this point we already know what x4 is from this equation down here. Once we have x4 and x3, we can easily solve for x2 here. Right, solving for x2, move these 2 terms to the other side. So that would be b2 minus a23 x3 minus a24 x4, and divide by a22. Then finally x1 b1 minus, and then move all these 3 terms to the other side, minus a13 x3 minus a14 x4, divide by a11. Okay, so once we get to that point, to this triangular system, right, it looks like a triangle, then it's much easier to solve. We can use the back substitution, and then we solve the system. Okay, let's take a look now on how we implement the Gaussian elimination.